Okay, so on to 6.4, which is titled Inverses of Trig Functions, but I like to title this one, Why Does Your Calculator Do What It Does? So the way that we're going to look at this is that you're going to figure out why your calculator gives you the answer that it gives, and how you would do that potentially without a calculator, knowing what your calculator would give. And the way we're going to start with this is talking about functions. Your calculator likes to calculate functions. They like you to put in a calculation and get one answer. So if you look at sine, cosine, and tan, they are functions when you have them written like this. So y equals sine x is a function. You put in an angle, you solve for a y value, and you only ever get one y value. So for example, if you're looking at the sine of something like pi by 2, the y value you get is 1. Or you take the sine of pi and you get a y value of 0. So that's all good, but then we're going to talk about inverse functions. So anytime we're typing in inverse sine or inverse cos or inverse tan, and if we were to look at these functions as one-to-one, they all fail the horizontal line test, which means that the inverse is not a function. So this is not one-to-one, right? The horizontal line test, you pass through more than one point, so it's not a function. If you took the inverse of cos, again, not a function. And if you took the inverse of tan, not a function. So what are we going to do? Well, your calculator restricts your domain of your inverse so that it only produces one y value. So the easier way of looking at this is actually drawing the inverse. So in an inverse, you're switching the x and the y's. So if we were looking at the inverse of sine, it would be a graph that looks like this one here. So you can see that you're starting here at 0, 0. At pi by 2, you're going up to 1. At pi, you're going down to 0. At 3 pi by 2, you're going here to, sorry, what did I say? Oh yeah, I'm talking, I can't do it backwards, but if you had an x value of -1, that would be a y value of 3 pi by 2, but you can think of it as backwards and then reverse it in your head, right? And then at 2 pi or at 0, you get a value of 2 pi. So all the way along this, as we've written it, it's not a function, because if I had said this properly and I'd said, okay, so what are we going to get as a y value if x is 0, let's say? So let's say x is 0. Oops, sorry, I'm in the eraser mode. So if we type in x is 0, I get a y value of pi, I get a y value of 2 pi, I get a y value of -pi, and I get a y value of -2 pi. And so all of a sudden, for that x value, I am getting more than one y value. So what we have to do is restrict the domain so that the inverse is a function. And the way that we do this is we take a section of the graph so that it passes the vertical line test. So you'll notice that this part is in purple. And that's because this is a part that if we cut out the rest of this graph, so if we went, this doesn't exist. So if we can restrict the domain from -1 to 1 and say what y values we get, for sine, we're going to look at the y values of -pi by 2 to pi by 2, which means that no matter what x value you put in for into the inverse sine, it will give you a y value something between -pi by 2 and pi by 2. So if we test this, if you plug in y equals the inverse sine of, let's say, 0.5, and you plug that into your calculator, I'm doing it now, so make sure your calculator's in degrees if you want an answer in degrees, because actually no, let's make sure, well, yes, it's easier in degrees. So let's make sure our calculator's in degrees just because it'll make sense. So another way of thinking about the domain of the range as being -90 or -pi by 2 to pi by 2 is 90 to 90. Let's just do it in degrees because it seems to make more sense, especially using a calculator. So if I were to type in inverse sine of 0.5, it gives me an answer of 30. So it gives me an answer somewhere in here. So 0.5, it gives me an answer of 30. It could have given me this answer up here. It could have given me this answer down here. So up here, I don't know if you can see this or not, but it only gives me an answer between -pi by 2 and pi by 2. So it gives me 30 degrees. If I were to do inverse sine of -0.5, it gives me, oops, inverse sine of negative 0.5, it's going to give me negative 30 degrees. And so you could pick any value. So we have to restrict the domain from -1 to 1 because your sine graph never goes above 1 and it never goes below -1, so that's a given. And in that restricted domain, we want to make sure that our output is a function. And so we make sure that we restrict it between -90 and 90 or negative pi by 2 and pi by 2. And that way we only get one answer. So you're just looking at this one section of the graph. If we did the same thing with cosine, what we want to look at is what it gives us. So if we want to restrict our domain, again, we restrict it to the purple part. So it's going to always give us answers between 0 and pi. So 0 and pi. And so why does it do that? Well, let's first off make sure that that's right. So if we hit inverse cos of 0.5, let's just keep on the 0.5 train, I get 60 degrees. So that's in here. If I pick something negative, so inverse cos of negative 0.5, oops, inverse cos, negative 0.5, I get 120 degrees. And so your calculator automatically gives you an answer between 0 and pi, or 0 and 180 degrees, so that it gives a restricted range for that domain. If we do the same thing with tan, okay, the tan graph's a bit of a funny looking one, but again, we can just take one cycle of tan because it's going to pass the vertical line test. And you can see here that we're going from negative infinity to infinity for my domain, but my range is going to get restricted between negative pi by 2 and pi by 2. And so again, if you typed into your calculator the inverse tan of, let's say, positive 0.5, so inverse tan of positive 0.5, I get 26.6 degrees. So let's say 27 degrees. And so if I type in inverse tan of negative 0.5, without typing it in your calculator, you can now start to guess what answer they're going to give me. 27 degrees is the reference angle. So you'll notice that if I were to draw this, it would give me this answer of 27. And if I typed in negative 0.5, it would give me an answer down here. It would give me negative 27 degrees. And let's just check that. So we type into your calculator inverse tan of 0.5, and you get, oops, sorry, inverse tan of negative 0.5 will help me, and I get negative 27 degrees. So what does that mean? Well, it means that your calculator will give you your answers that are positive. All of them come out in the first quadrant. So for every single one of the graphs, so if we just draw these quickly, so we call this our sine, we call this our cos, and we call this our tan, every single one of them will give a positive answer in the first quadrant. So the restricted domain on the inverse is that every single answer is in the first quadrant. It gives you your reference angle. But then it varies. For sine, it gives you this inverse sine of a negative ratio. It gives you the angle down here. For cosine, it gives you the angle here. And for tan, it gives you the angle here. So for example, for inverse sine, it would give us 30 degrees for positive 0.5. It gives us negative 30 degrees for negative 0.5. For cosine, it gave us 60 degrees. Then it gave us 120 degrees. And then for tan, our calculator gave us, what was it, 27 degrees. And then it gave us negative 27 degrees. The calculator fits these restricted domains. So it fixed the or restricted ranges, sorry, from the domains. So why are they different? Why is sine and tan both first and fourth quadrant and cosine is first and second quadrant? Well, if you look at the CAST rule, C-A-S-T, the calculator, the easiest answers they can give, the smallest answers they can give are these two, because they read this one in a positive direction and they read this one in a negative direction. And both of these give you the reference angle. But for cosine, in the first and the fourth quadrant, everything's positive in the first quadrant, but cosine's positive in the fourth quadrant. So they can't give you a negative answer there, which is why cosine, they have to give you the answer in the second quadrant. So cosine's the only weird one that they don't give you the answer in the fourth quadrant, and it's because they can't, because that's actually a positive value for cosine. So this is sort of the introduction to the lesson. It's in my head, it's titled, what would your calculator do? So for example, instead of me asking you, so the difference in the questions are, what you've been asked up until now is something along the lines of this. They'll say y equals sine x. And what they would do is say, okay, what is the value of x when sine x equals root 2 over 2? So to solve that, you'd go x equals the inverse sine of root 2 over 2. And then you'd have to draw, so don't be writing this because this isn't the answer, but you'd have to draw this and you'd say, okay, cos or sine is positive in the first quadrant and in the second quadrant. So you'd say root 2 over 2 is a reference angle of 45 degrees. And so it would be here and here. And so my two answers, depending upon if we want radians or degrees, let's do radians, would be pi by 4 and 3 pi by 4. And that would be my answer. There'd be more than one. In fact, there'd be a ton of answers. There'd be pi by 4 in every single cycle of sine. There'd be 3 pi by 4 in every single cycle of sine. It's endless. There's endless and endless and endless answers. But the way this question was written is they didn't ask it as what value of x will make this true. Instead, what they've done, if my eraser will actually erase, there we go. What they've done is written it as an inverse sign, which is when you know that they're asking you for the answer in the restricted domain. So anytime the question says inverse sign, so that's written for you instead of just sine x equals root 2 over 2, that's when you know you have to give an answer in the restricted domain. So for inverse sign of root 2 over 2, I'm giving the positive answer. So it has to be either here or here. Because it's a positive answer, I know the answer is going to be here. So my only answer would be the pi by 4. And if you're questioning how I knew it was pi by 4, don't forget that this is 1 over root 2 rationalized. So it's opposite over hypotenuse, or y over r. So it's your 1, 1, root 2 triangle, which is why I knew that it was pi by 4. All right, moving on to the next question. So this one's asking me to give the answer for the inverse cos, so the restricted domain, when it's a negative value. So your two choices are here and here for cos. Since it's negative, you know that cos is negative in the second quadrant, so I'm going to put it here. Adjacent is 1, hypotenuse is 2, or x is 1, and r is 2. And I put a negative here, so it's my 1, 2, root 3 triangle. So the angle in here is going to be pi by 3. Pi by 3 is across from root 3. So my answer would be, in the second quadrant, it would be 3 pi by 3 minus the reference angle, which means my answer would be 2 pi by 3. And because these questions didn't ask you whether the angle should be radians or degrees, I'm doing radians just to give you as more practice with radians. But if I don't specify, I mean, this one could have been 45 degrees, and this one here could have been what? That would have been 60 degrees. So 180 minus 60 would be 120 degrees. So either of those two answers for this one would be fine. All right, I recommend pausing the video and giving this one a go. But just looking at it with you, as soon as I see that inverse tan, I'm thinking restricted domain. Because it's negative, I know that it's going to be in the fourth quadrant. This is going to be my 1 over root 3. So my opposite is 1. My adjacent is root 3. And it's a negative 1, so it's my 1, 2, root 3 triangle, which makes this reference angle a pi by 6. So my answer would be negative pi by 6. So we're not going to read it as a 0 to 360. We are going to be reading it as your calculator would. So it's negative pi by 6 or negative 30 degrees. And now what I want to show you is that you could have used your calculator to solve all of these ones. So if you looked at the first one, we're going to do some calculator questions in a sec, but just while you're doing that one, if I type inverse sine of root 2 divided by 2, I get 45 degrees, which I know in radians is pi by 4. So we're not doing anything out of the ordinary. We're just getting the answer that your calculator would give in a restricted domain. So I just want to prove to you that if you did touch a calculator, if you did the inverse sine of root 2 over 2, I'm expecting my answer to be in the first quadrant, 45 degrees. And if you type that into your calculator, it was. If I type inverse sine of, that should have some brackets, inverse sine of negative root 2 over 2, I'm expecting my answer in the fourth quadrant, read in the negative direction. So there we go, first quadrant. Fourth quadrant, read in a negative direction. If I did it for cos, my positive answer should be in the first quadrant. So inverse cos of 0.5 or 1/2 is 60 degrees. Inverse cos of negative 1/2, I'm expecting it to be 120 degrees. Double checking with your calculator, inverse cos of negative 0.5, and I get that 120, which we've already been talking about. All right, so if I did the inverse tan of root 3 over 3, I'm expecting it to be in the first quadrant. And yes, my calculator gives me 30 degrees, which means I'm expecting my calculator to give me negative 30 degrees for the negative answer. So the calculator always answers in the restricted domain we've been talking about. So that's the thing you notice. The calculator gives the answer in the restricted range. Sorry, I keep saying domain, but I've got in my head they're switched because I think of them the other way. All right, so using a calculator, find the angle measure associated with the following trig function. So now what we're doing is we're just doing simple button pushing. So I want to know in degrees. It says round the degree measure to the nearest tenth of a degree. And again, this is just really proving to you, if I type inverse cos of 0.2689, I'm expecting an answer in the first quadrant. And is it? Bing, 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 74.4 degrees. If I do this for sine, inverse sine of 8.205, I expect my answer in the first quadrant. What happened? I got error. Why? Well, we've been talking so much about restricted range. We've been saying, what y values can we get? Oh, okay, so it's got to be between negative 90 and 90 degrees. That makes sense. But don't forget there was a restricted domain as well. I can only put in x values between negative 1 and 1. If you think of your sine graph, right, and I know we're doing it on the side, but I'm horrible at drawing it on the side. So if you think about this guy, you never get values that are greater than 1 and less than negative 1. So this value that you're taking the inverse sine of has to be between negative 1 and 1, or you're not allowed to do it. Well, what about secant? First of all, the question is, how the heck do I plug this into my calculator because I don't have a secant button? So what I start off with is rewriting the question the way it would have started. Secant theta is equal to 1.1677. Now this is an inverse. Secant is the inverse of cos. So if I said that this is 1.1677 over 1, the reciprocal would be 1.1677 in the denominator. So really what this is asking me to do is find inverse cos of 1 divided by 1.1677, which is less than 1. So my calculator should allow me to do it. I expect my answer to come out in the first quadrant. And if I hit inverse cos of bracket 1 divided by 1.1677, I get 31.1 degrees to the nearest tenth of a degree. And then cotan, because this is negative, I'm expecting my answer to come out in the fourth quadrant. I'm going to type it in as the inverse tan of negative 1 divided by 1.265. And if I type that in, I get inverse tan bracket negative 1 divided by 1.265, and I get negative 38.3 degrees. So this lesson is all about trying to kind of get you more comfortable with why your calculator gives you what it does, so that in the next lesson, when we use our calculator to solve trig functions, you understand that they're giving you only a specific answer, but there's more than those answers out there. These are just the only answers that fit into a restricted domain, so that my inverse is a function and my calculator can give me one answer. So what are some of the questions going to look like? Well, they're going to look something like this, where you're going to notice you have the cos of the inverse cos of root 3 over 2. So you do the brackets first. So the first thing I would do is take the inverse cos of root 3 over 2. So I'm thinking positive root 3, 2, 1. So I'm expecting my angle to be 30 degrees or pi by 6, depending upon what you want are better with or you want practice with. And then again, I'm looking at the cos of pi by 6, which is going to be root 3 over 2. So these undid each other. The inverse, or the cos of the inverse cos, left me with just root 3 over 2. Well, that's pretty easy. So what if I did the tan of the inverse tan of 1? I'm expecting my answer to be 1. Is it? Well, let's check. So if I took the inverse tan of 1, so we're thinking opposite, it's first quadrant because it's positive. First, it's 1 over 1, so it's my 1 root 2, which is, let's say, 45 degrees this time. You can switch between radians and degrees, it doesn't matter. And then the tan of 45 degrees is 1. Oh, that's nice. So then people go to this one and they're like, oh, the answer is 1.8. I'm not going to do any work. Why is that wrong? Well, the inverse cos of 1.8 is an error. You cannot take the inverse cos of 1.8. It has to be between -1 and 1. So this answer does not exist. So just be careful. So I was just showing you, you kind of get on this roll where you're just like, oh, these are easy. The answer is √3/2. The answer is 1. The answer is 1.8. And you get that one wrong because you have to make sure that not only are you giving restricted domain or a range, you are also giving restricted domain. So this guy, what if we went the other way? So what if we did the inverse tan of tan? So again, I expect them to undo each other. My answer I'm expecting is pi/6. The biggest thing you want to make sure is that the answer they're giving you in here fits the restricted domain, or sorry, range. I keep saying domain. So is pi/6 in my positive or in my realm of answers for inverse tan? It is. If I wanted to check, I'm doing the inverse tan of the tan of pi/6. Tan of pi/6 is 1, 2, √3. So I'm doing the inverse tan of opposite over adjacent, so 1 over √3. I don't feel the need to rationalize. The inverse tan of 1 over √3 is pi/6. So yeah, it does it the same way. What about this question? First thing I want to check is 3/4 in a restricted domain for cos? And it is. So this would be taking the inverse cos. This is 45 degrees, so it's be an inverse cos of 135 degrees, which would still be, oh sorry, I wrote that wrong. Inverse cos of, let me just erase that. Getting ahead of myself. So if we've got 3π/4, I'm looking at an angle in the second quadrant, which is in my restricted domain. My opposite, my hypotenuse, and my adjacent. Okay, and so then I'd be looking at 1 over √2. This would be -1 over √2. And then the inverse cos of -1 over √2 is 3π/4. So really all I had to check was that this was in the restricted domain. So when I get a question like this one, and I go, okay, so sine has to be between -π/2 and π/2, and here they're giving me an angle of 3π/4. My calculator cannot physically give me an answer of 3π/4 because it's not in its restricted range. It's not an output. So I have to think of what would my calculator give me? Well, if I look at CAST, C-A-S-T, sine is positive in the second quadrant, so I would put it into the first quadrant for my calculator. So my answer is going to be π/4. If you want some more steps of how to get there, I mean, you could actually plug this into your calculator. You could do inverse sine. This is 3π/4, so either put it in degrees or make sure your calculator is in radians. So I'm going to do the inverse sine of the sine of 3π/4. Right? And it gives me 0.78, which isn't super helpful. But if I plug in pi divided by 4, I get 0.78. So they are the same. Alternatively, plug it in degrees and then convert your answers to radians. Really what I want you to get from this is that your calculator cannot give you outputs that are not in its restricted range. That's the moral of the story. So just learning about what would your calculator give you. And then the last couple are a little bit different. So these ones, it's not something undoing itself. These are actually different trig functions. So we've got the sine of the inverse tan of -1. So we would start by saying, okay, I'm going to take the inverse sine of -1. So -1 over 1 is going to be tan in the fourth quadrant. So it's going to be my 1, 1, √2 with my negative here. And so the inverse tan of -1, that's my reference angle of 45 degrees. So this would be -45 degrees. Then I'm looking for the sine of -45 degrees, which would be y over r, or -1 over √2, which rationalized, right? Multiply numerator and denominator by √2 over 2. I get -√2 over 2. And again, it wouldn't matter whether I put -45 or -π/4, whatever you're comfortable in at this point, please feel free to use whatever will make sense for you. All right, the last question, the inverse cos of the sine of π/2. So the first thing I want to do is find the sine of π/2. It's up here, so it's a 0, 1. Sine follows y, so it'd be 1 over 1, or just 1. Alternatively, you could think of the graph. So this is a graph of sine. The sine at pi by 2 has a y value of 1. But regardless, we're finding the inverse cos of 1. Now I have to figure out what angle would I get if I took the inverse cos of 1. And again, you can use a calculator if you want to, or you can kind of look at how to do it by hand, which is always a good thing to do. So cos follows x. So you're looking at where x is 1, and the only place that's going to happen is here. Or you could think of the graph, it looks like this. The only place that cos has a value of 1 is here, so the answer would be 0. Whether you want your answer in degrees or radians depends upon what your question was in. So I would say 0 rads, which would be the same as 0 degrees. All right, it's a weird lesson, but if you kind of just go with it and think of it as I'm learning what my calculator gives as answers, then it should be okay. Good luck.